Hello friends, in this video today we are going to discuss Newton's forward interpolation formula and Newton's backward interpolation formula for equal width. So already in my last videos we have discussed Newton's divided difference formula and Lagrange's interpolation formula for equal width. So first we will see the finite differences. Suppose that the function y equal to f of x is tabulated for the equally spaced values x equal to x naught comma x naught plus h and so on up to x naught plus n into h, giving y naught, y1, y2 and so on up to yn. Here, to determine the value of f of x or f dash of x of some intermediate value of x, the following type of differences are found useful. So here we are going to discuss two differences. One is forward difference and another one is backward difference. So first we'll see the forward difference. This del operator is the forward difference operator. So if I want to find del of y naught, it is given by y1 minus y2. Del of y1 is given by y2 minus y1. Del of y2 is given by y3 minus y2 and so on up to, in general, del of yr equal to yr plus 1 minus yr. This indicates the first forward difference. Similarly, del square of y naught equal to del of y1 minus del of y naught, del square of y1 equal to del of y2 minus del of y1 and so on up to del square of yr equal to del of yr plus 1 minus del of yr indicates the second forward difference. In general, we can define del raised to p of yr equal to del raised to p minus 1 yr plus 1 minus del raised to p minus 1 yr. This is the pth divided difference. Now we'll see backward difference. This reverse del indicates the backward difference operator. So here we find del of y1 equal to y1 minus y0, del of y2 equal to y2 minus y1, del of y3 equal to y3 minus y2 and so on, indicates the first backward difference. Similarly, del square of y1 equal to del of y1 minus y0, del square of y2 equal to del of y2 minus del of y1 and so on, indicates the second backward difference. Now we will see the Newton's forward interpolation formula as well as the Newton's backward interpolation formula. So let us consider the function y equal to f of x takes the values y0, y1 and so on to yn corresponding to the values of x0, x1 and so on to xn of x. Let these values of x be equispaced. It means width is equal here. Then y of p equal to y0 plus p into del of y0 plus p into p minus upon 2 factorial del square of y0 plus p into p minus 1 into p minus 2 upon 3 factorial del cube of y0 and so on up to is called Newton's forward interpolation formula. Here p is calculated by x minus x naught upon h. So similarly, the Newton's backward interpolation formula is given by yp equal to yn plus p into reverse del of yn plus p into p plus 1 upon 2 factorial del square of yn and so on up to is called Newton's backward interpolation formula. Here p is calculated by x minus xn upon h. Here x0 indicates the first value, xn indicates the last value and x is the given question. And already we know that h is what? The width. Now we'll take one example. Find the value of y when x equal to 4 from the following table. Here the values of x are given as well as the values of y are given corresponding to the values of x. So in this example, they have not mentioned which formula we have to use. So the formula is decided by seeing the value of x. If the value of x is nearer to the xnth value, then we have to use backward Newton's backward interpolation formula, and if the value of x is nearer to the value of x naught, then we will use Newton forward interpolation formula. First we will prepare the table. First I will write here the value of x and corresponding to values of y. The first value is x naught, x1, x2 and x3. So this is what the xnth value. Similarly, y naught, y1, y2, y3 and this value is what yn. So first I will find del operator, the differences. So 2 minus 1 is 1, 1 minus 2 is minus 1, 10 minus 1 is 9. This is the first difference. Similarly, I will find del square of y, that is second difference. Minus 1 of minus 1, this become minus 2, 9 minus of minus 1 equal to 10. This is second difference. And lastly, I will find del cube of y, that is 10 minus of minus 2 is become 12. So already I have told we have to find the value of y when x equal to 4, and x equal to 4 is nearer to the last value. Therefore, I am using here Newton's backward interpolation formula. So I will write the formula here: yp equal to yn plus p into del of yn plus p into p plus 1 upon 2 factorial del square of yn plus p into p plus 1 into p plus 2 upon 3 factorial into del cube of yn upon 3 factorial. So here the difference between two numbers in x is 1. Therefore, the value of h is here 1 and x is 4, the given quotient, and xn, this last value is 3. So I will find p here, p becomes 1. So therefore my equation number 1 becomes y of 4 yn, so this last value, that is 10 plus p is 1 into delta of yn is 9. So because we are using backward interpolation formula, I will take the last values plus 1 into 1 plus upon 2 factorial is 2 into 10, this value, plus 1 into 1 plus 1 into 1 plus 2 upon 6 into 12. So this 12 value. So after calculating, I will get y4 as 41. Thank you.